Hello! Today we're going to do lesson 43, trigonometry, sine, cosine, and tangent. Now, trigonometry is something new for you guys. We're going to start looking at this, and it's really fun. It's very different and very cool. So I'm sure you're going to love it. So let's look at these two triangles first. Now, what we have to remember about trigonometry is that is the study of right triangles, angles that have right angles. So let's look at these two. Notice that these two have the same shape, or very similar shape, but they have different sizes. So notice how this angle here is 30 and this one is 30 also. Then we have the 90 and 90, and then we can then say that this is 60 and this is also 60. So now we are sure that these two triangles are similar. They're not the same, they're not congruent because they don't have the same size. They have different sizes, but they are similar. So before I introduce to you what is trigonometry, what is sine and cosine and tangent, I want you to realize what's happening. So let's look at these triangles and the relationships between their angles and their sides. Right now, I want to focus on the 30-degree angle. So look at, for example, here the 30. If I'm standing here, the one that is touching is called adjacent to this angle 30. The one that is across from is called opposite. And then the one that is opposite to 90 is the hypotenuse. And notice that if I do the same here, we're going to have the same. Okay, so let's look at the relationship. What happens if I put the opposite over the hypotenuse? Well, the opposite is 2, right? Here is 2. And the hypotenuse is 4. And if I reduce that, that's 1/2. Now let's see what happens in the other one, in the bigger triangle. Well, the opposite is 50 and the hypotenuse is 100. And if I reduce that, it's also 1/2. So notice it's the same thing. If I compare, or if I find the ratio of the opposite side of an angle and the hypotenuse, is going to be the same no matter the size. Let's see if it's true with something else. What about adjacent? Well, if I compare the adjacent, which is 2 square root of 3, over the hypotenuse, which is 4, the answer is going to be 1/2 square root of 3. And if I do it on this side, it's going to be the 50 square root of 3 over the 100, which is also 1/2 square root of 3. So once again, the comparison or the ratio is the same. And then finally, if I compare opposite over adjacent in both of the triangles, we will see that we also get the same answer. The first one would be 2 over 2 square root of 3. If I simplify that, that is 1 over square root of 3, which is square root of 3 over 3. And again, you can put this in the calculator and then get an approximate answer with decimals. But if I do it here, I get exactly the same. 50 over 50 square root of 3. The 50's cancel, and so it's 1 over square root of 3. And if I rationalize, then I get the same answer, square root of 3 over 3. So what's happening and what you should know is that no matter the size of the triangle, we can have another 30, 60 degree triangle, and any comparison of the opposite over the hypotenuse or the opposite over the adjacent or the adjacent over the hypotenuse, it's all going to have the same ratios that we got here, the same answers. And that's what trigonometry looks at. It looks at this relationship between the angles and the sides of a right triangle. Now, because mathematicians like to make their life easy, they gave these relationships a name. So we have here the first one is called the sine. And the sine of an angle, I'm going to put it angle A, it's going to be the opposite of that angle, the opposite side, over the hypotenuse. Then we have cos or cosine, and that's going to be the adjacent over the hypotenuse. And finally, we have tan, and that's going to be the opposite of that angle over the adjacent. So we're going to learn here how to find the sine and cosine of A and B. But before we do that, I want to give you something to help you remember, which is called SOHCAHTOA. SOHCAHTOA is something we use to remember these three trigonometric functions. S stands for sine, O is opposite, and H is hypotenuse. So whenever I say SO for SOHCAHTOA, I'm going to remember that sine is opposite over hypotenuse. Then I have cosine, which is adjacent over hypotenuse. And then I have tangent, which is opposite over adjacent. So this is an easy way to remember these three relationships. So we're going to be using those relationships to find the sine, cos, and tan of each of these angles in a more general way. So let's start with sine of A. If I'm looking for sine of A, I have to give it from the perspective of A. So who is the opposite side of angle A? Well, if opposite is the one across, so it's going to be A over the hypotenuse, because it's opposite over hypotenuse. So the hypotenuse in this case is C. So the sine of A is A over C. Then if we have to find the cos is going to be the adjacent over the hypotenuse. So adjacent is the one here touching the angle, so that's going to be B, and the hypotenuse is C. Finally, if I want to find the tan of angle A is going to be the opposite, which we already know is A, over the adjacent, which we already know is B. And those would be the answers. Now let's look at it from the perspective of B. What is sine of B? Well, now I have to stand here and look for the opposite side of angle B, which in this case is B. The hypotenuse doesn't change, is C. Then we have to find cos of angle B, and again is the adjacent, the one side that is touching the angle. So in this case, it's going to be A, and the hypotenuse is C. Finally, if I look for tan of B, it's going to be the opposite, which we said is B, over the adjacent, which we said was A. Now I want you to notice that there is some kind of relationship here also. Notice how AC, the sine of A, is also the cos of B. So we can see that the sine of the first angle is the same, or is congruent to the cosine of its complement. And then what do we notice here for AB and B over A? That the tangent of one of the angles is the inverse of the tangent of the other angle. So using this information, we're going to now solve some triangles. The first example says, find the sine of A, cosine of A, and tangent of B. So remember, we have to look from the perspective of the angle. So I'm going to draw myself here and say, okay, what was sine? Well, if we remember about SOHCAHTOA, sine is opposite, so the opposite of A, which is 4, over hypotenuse, which is 7. And what you want to do is you want to put that in the calculator, 4 over 7, or 4 divided by 7, and write the approximation, which is 0.57. Make sure you try it there and see what's happening. And that's it. That's the sine of A. Notice we don't know what angle A is. We just know that the relationship between the opposite and the hypotenuse is 0.57. Let's look at the cos. Cos of A is adjacent, which is 5.74, over hypotenuse, which is 7. And again, if you put that in the calculator, the answer will be 0.82. Finally, they ask us to find tan of B. So now I have to look from the other perspective, from angle B. So I have to draw myself here. And tan is opposite over adjacent. So opposite of B is 574, and adjacent is 4. 4. And if I put that in the calculator, I get 1.435, or I can round to 1.44. And that's it. Very simple. You just have to memorize these of SOHCAHTOA so that you can visualize where they go. Let's look at this other example. In this one, they ask for sine, cos, and tan of angle A. So all of them from the same angle. So we're going to be here because we have to look from the perspective of angle A, and we'll find sine, cos, and tan. Now again, remember, we can write here SOHCAHTOA to help us remember what is each one of these relationships. Sine is opposite over hypotenuse, so opposite is 8, hypotenuse is 10. And then, if I put in the calculator, is 8/10. For cos is adjacent, which is the one touching the angle, so 6 over hypotenuse, which is 10. And finally, tan is going to be opposite over adjacent. So opposite is 8 over adjacent 6. And if I put that in the calculator, I get 1.3 repeating. And that's all I have to do. Now, we're going to talk about the inverse of the sine. So let's read this carefully. It says, the sine of 30 is 0.5. The inverse sine of 0.5 is 30 degrees. So what is this for? How do I use it? Well, sometimes we know the value of the sine, but we don't know the angle, like in our previous example. We don't know what A is. So can I find A? Yes, we can, because we can use the inverse sine of 0.8, and that would give us the answer. So let's look at an example here. It says, calculate the measurement of angle A. So again, notice, we don't have A, but we can find sine of A. What is sine A? Well, it's opposite, 12, over hypotenuse, 13. If I go to the calculator and I put, you have to look for in your scientific calculator, you have to look for something that says shift or inverse. And what you're going to do is press that button, shift, and then press Sine. And in your calculator, it should show something like Sine -1. That's what you want. So when you do that, what we're looking for is the inverse sine of 12 over 13. So if you put that in the calculator, you get 66.93 if we round it. Now make sure you have your calculator in degrees, because if not, it will give you the answer in radians. Now let's see what happens if I use cos instead. So let's use cos A, and in this case it would be 5, the adjacent, over 13. If I do that, and I'm going to find the inverse of cos, and again I put here 5 over 13, the answer will be 67.38. And in this case, notice that if we round both of them, they both round to 67. Now, remember, these answers are approximate, so we're looking for the approximate measurement of the angle. And even though they're a little different, they both round to the same number. And that's what we want. Now I want you to pause the video and do this practice by yourself. Remember to use the SOHCAHTOA to help you, and then you can check your answers with my process. So let's look at it. First of all, remember SOHCAHTOA. The first one, they ask for sine of A, so sine of A is opposite over hypotenuse, which is 15 over 17. And again, you can find the answer by putting that in the calculator. You just put 15 divided by 17, and the answer is 0.88 approximately. You can also leave the exact answer, which is the fraction. For cos, it's adjacent over hypotenuse, so it's 8 over 17. For tan is opposite over adjacent, which is 15 over 8. That one is looking from here. Now from sine B, we have to look from here, and it's going to change a little bit. Remember, we found even a trick. that sine of A is going to be cos of B, so I can even put here 15 over 17. I already know my answer. Cos of A is the same as sine of B, so 8 over 17. And tan of A is the reciprocal, so 8 over 15. Now, if you did it by doing SOHCAHTOA, that's also fine, no problem. Now they're asking for the measurement of A and the measurement of B, of the angle A and B. So let's use either of these to find it. So I'm going to use, for example, the inverse sine, or arc sine is also called, of 15 over 17. I would suggest that you use the fraction, not the decimal, because that would give you a more exact answer. That's going to be 61.93 degrees. And then for B, I'm going to also use sine, but in this case, the sine of B is 8 over 17. And the answer of that is 28 7/100. Now notice that these two are complementary. If you add 61.93 plus 28.07, the answer is going to be 90 or very close to 90 because they are complement. They're these two angles that should give us 90 degrees. Look how cool this is. A lot of great learning in this lesson. I hope you got all your answers correctly. If you have any questions, let me know in the comments, and I'll see you in the next lesson.